Hello everyone. Today's topic is relative stability of carbocations and carbanions. Okay, and I will take into account these JEE and NEET questions for to explain this topic. Okay, so first question is it is from JEE Main 2013. The order of stability of the following carbocations. You have three carbocations. You just tell me what is the order of stability. Options are, I will give you options. First option is 3 is greater than 2 is greater than 1. B option is 2 is greater than 3 is greater than 1. C, it is 1 greater than 2 greater than 3. And D option is 3 greater than 1 greater than 2. Yes, tell me what is the order of stability. Yes beta. बोलिए. Okay, D option. 3 is greater than 1 is greater than 2. Very good here. How do you know this? See, in the first case, it is allyl carbocation. So allyl carbocation, it is stabilized by resonance. It is stabilized by resonance, right? But there are only two canonical structures. Okay, now in second case, this is first case. In second, this carbocation, it is stabilized by plus I effect and hyperconjugation. See, it is stabilized by, that is resonance. Okay, delocalization. Okay, and in second case, it is stabilized by no bond resonance, that is hyperconjugation. Main role is played by hyperconjugation, and there are only two hyperconjugated structures. Okay, in first case there are two, in second case hyperconjugated structures are two, in third case we have benzyl carbocation. So in benzyl carbocation, there is more delocalization of positive charge, and more is the delocalization of positive charge, more stable is the carbocation. Very good, Ashish. See, due to more number of resonating structures, more is the delocalization of positive charge, and in this way benzyl carbocation is most stable, and second means after that there is allyl carbocation and then propyl carbocation. So option D is correct. So sorry, D option is correct. Is it okay? Got it? First of all, try to identify which effects are operating, resonance or hyperconjugation or inductive. Most effective is resonance, and then hyperconjugation, and then inductive. Okay, so this is the order. first number is given to resonance, second number is given to hyperconjugation, and third to inductive. Okay, in this case, first and third, in these cases there is a resonance effect, but in first case there are only two canonical forms, but in third case there are more number of canonical forms, resonating structures. That's why delocalization of positive charge is more in third than in first. And second is, in second case there is only hyperconjugation and plus I effect. That's why it is at the end. Okay, so most stable is benzyl, then allyl, and then propyl. Okay, next, second question. Okay, write down the correct stability order of the following. The correct stability order of the following resonance structure is CH2 double bond N double bond N plus minus. Second is CH2 positive N double bond N negative. Third is CH2 negative N triple bond N positive. And fourth one is CH2 negative and double bond N positive. Okay, this is question from IEEE 2009. Yes, tell me, what is the order of stability? Yes, beta. What is the order of stability? See, first of all, let us calculate the number of covalent bonds. Okay, different options. So A option is first greater than second greater than fourth greater than third. B option is first greater than third greater than second greater than fourth. C option is second greater than first greater than third greater than fourth. And D option is third greater than first greater than fourth greater than second. Yes, beta. What is the correct option? Yes. First of all, calculate the number of covalent bonds. The one which has more number of covalent bonds is most stable. See, number of covalent bond in the first case 1, 2, 3, 4, 5, 6. In first case, number of covalent bonds are 6. In second case, number of covalent bonds are 1, 2, 3, 4, 5. In third case, number of covalent bonds 1, 2, 3, 4, 5, 6. And in the fourth case, number of covalent bonds are 1, 2, 3, 4, 5. try once again. Swasti, where are you? Just try beta. So number of covalent bonds in first and third case are 6. So that means first you should see whenever resonating structures are given, okay, then first of all, more the number of covalent bonds, more stable is the resonating structure. Okay, stability of resonating structure depends upon number of covalent bonds. That means first and third, they are more stable than second and fourth. Okay, now compare first and third. Let us compare first and third. So in first case, you know, negative charge is on more electronegative atom, but in third case, negative charge is on less electronegative atom. That means first is more stable than third. Negative charge should be on more electronegative atom. Okay, so in first case it's true, but in third case it is different. Okay, now come to second and fourth. Out of second and fourth, which one is more stable? Yes, now you can tell. It is very easy. See, in the second case, negative charge is again on more electronegative atom, and in fourth case it is on less electronegative atom. Again, second is greater than fourth. Got it? Okay, very good. So option B is correct, beta. Okay, Ashish, good. Option B is correct. Good. So this is the second question. Now come to third. Third question. Yes. Wait, beta, wait. Yes, the correct stability order of the following species. The correct stability order. Yes, Swasti, very good. The correct stability order of the for the following species. First is this one. This is first one. Then second, third, fourth. Okay, this is from 2008, AIEEE 2008. So first option is second is greater than fourth, which in turn greater than first, then third. B option is first greater than second, greater than third, greater than fourth. C option is second, first, fourth, and third. And D option is first greater than third, greater than second, greater than fourth. Okay? Yes, tell me which order is correct. Yes, beta, tell me. 1, 2, 3, 4. Option A. Say in first case. Okay, let us try from first. See, positive charge is on this carbon. There is resonance from one side and 3 alpha hydrogens on the other side. In the second case, 2 alpha hydrogens on one side, 3 alpha hydrogens on the other side. In third case, okay, sorry, here it is like this, sorry. It is like this. So there are 3 plus 3 alpha hydrogens. Okay, in this case, resonance from one side, from oxygen side, and 3 alpha hydrogens on the other side. And here only 2 alpha hydrogens. Tell me. See, here we should look at resonance plus hyperconjugation. Whenever carbocation or free radical is there, you will see resonance and hyperconjugation. These are the main stories. Okay. Now tell me. Obviously, first and third should be more stable than second and fourth. First and third, they are more stable than second and fourth. First, divide like this. So they see, second and fourth can never be more stable than first and third. First and third are more stable because there are lone pair. See, whenever I think you see the more electronegative atom, but you should see the lone pair. Lone pair in conjugation with positive charge. Okay, so there is resonance from one side and hyperconjugation from other side. Okay, and there are total 6 hyperconjugated structures. 6 hyperconjugated structures. Here 5 hyperconjugated structures. Number of alpha hydrogens is equal to number of hyperconjugated structures. More is the resonance, more is the stability. More are the resonating structures, more is the stability. More is the hyperconjugation, higher is the stability. More is the number of hyperconjugated structures, more is the stability. But resonance is dominating over hyperconjugation. That keep in mind. Okay, sorry, I wrote it afterwards. Okay, I forgot to write, draw that one methyl group. Okay, so in this case, in the third case, there are 3 hyperconjugated structures and resonance. In last case, there are only 2 hyperconjugated structures. So obviously, first is greater than third, because in first case there is resonance on one side and hyperconjugation on the other side, more hyperconjugation. In third case even there is resonance from one side, hyperconjugation from the other side, but hyperconjugation in third is less than that of first. Okay, that's why first is more stable than third. Then out of second and fourth. In second case there are 5 hyperconjugated structures, but in fourth case there are only 2. That's why second is more stable than fourth. Okay, so that means option first, third, second, fourth, D option is correct. Okay. Now question number 4. Now in question number 4, Write down among the following the least stable resonance structure is. Least stable resonance structure is. It is from 2007. The first option is try to figure out least stable resonating structure. Okay, so these are the four resonating structures. You should show which one is the least stable. Least stable resonating structure. Out of these four least stable resonating structure. So see, first point was number of covalent bonds, right? More the number of covalent bonds, more stable is the resonating structure. Second is negative charge should be on more electronegative atom, and positive charge should be on less electronegative atom. Third, like charges should be away from each other. For stability, okay, and opposite charges should be close to each other. Okay, very good. Ashish, tell me why A option is of that kind, least stable. Because in this case, like charges are on the adjacent atoms. See, like charges are on adjacent atoms. That's why this structure is least stable. There is no other resonating structure where like charges are on the adjacent atoms. Only in A option, like charges are close to each other. They are on the adjacent atoms, though there is more repulsion. That's why A option is correct. Very good, Ashish. What about others? Are you getting all these explanations? Yes, beta. Anyone who has doubt in it? No doubt. Okay. Oh, okay, okay, great. Mhm. Okay, next question is uh, stability of carbanions. Stability of carbanions in the following. First one is R C triple bond C negative. Second option is double bond C H negative. R3C CH2 negative. Is in the order of first greater than second, second greater than third, third greater than fourth. B option, second is greater than third, third is greater than fourth, fourth is greater than first, fourth is greater than first, sorry, fourth is greater than second, second is greater than third, third is greater than first. D option, first is greater than second, sorry, first is greater than third, third is greater than second, second is greater than fourth. Yes, tell me. So what is the order of stability of carbanion? This is from NEET 2008. Yes, beta. Tell me, what is the order of stability? D. A, D, B, C, D. All have different options. See, first of all, see the negative charge should be on. Negative charge is stable on more electronegative atom. We have discussed just before it. Negative charge is stable on more electronegative atom, right? And electronegativity is proportional to S character. That is, sp hybridized carbon is more electronegative than sp2, which in turn more electronegative than sp3. So in first case, what is the hybridization of carbon? Obviously sp, because there are one sigma bond and one lone pair. In second case, what is the hybridization? sp2. Okay. In third case, again hybridization is sp2. In fourth case, hybridization is sp3. Right? Do you know the concept of hybridization? Number of sigma bonds plus number of lone pairs, that is equal to hybridization. In organic chemistry, we go like this. If total is 4, hybridization is sp3. If it is 3, hybridization is sp2. If it is 2, hybridization is sp. In first case, there is one sigma bond and one lone pair. In second case, see, there are two sigma bonds and one lone pair. In third case, again there is one sigma bond, two sigma bonds and one lone pair. Two sigma bonds, one lone pair. In fourth case, there are two sigma bonds and one lone pair, because two hydrogens are attached. Okay. So first of all, first case, in case there is sp hybridization, that is, this carbon is more electronegative, so negative charge is more stable on more electronegative atom. So obviously first is most stable. First one is most stable. Now fourth is least stable. Now we left with second and third. So obviously, see, there are more number of pi bonds. Okay, there is only one pi bond. Okay, so obviously second is more stable than third one. So this is the order of stability. Right? So A option is correct. First, second, third, fourth. That's it. Okay. Now, next one. And this is question number, yes, question number 6. Am I right? So, question number 6 is base strength. Base strength of first CH3, CH2 negative, CH2 double bond, CH negative, negative. Okay. Base strength is in the order of A option is second is greater than first is greater than third. B option is second is greater than first is greater than second is greater than third is greater than second is greater than first. C option is first, third and then second. D option first, second and third. Yes, tell me, what is the order? basic strength means strength of base. It is proportional to electron donating power. Okay, or inversely proportional to strength of conjugate acid. A means second is greater than first. Wrong, beta, wrong. Say, first of all, you can say the hybridization. In this case, hybridization of carbon is sp3, sp2 and sp. That means it is most electronegative, less electronegative, and here it is least electronegative. So that means electron donation is maximum in the first case and least in the third case. So that means first is most basic because negative charge is on the less electronegative atom. So electron donating power is more. And then it is second and then third, obviously, because it is most electronegative carbon. So its electron donating power is least. Okay. Second thing, just get its conjugate acid. So conjugate acid of first is ethane, conjugate acid of second is ethene, and conjugate acid of third is ethyne. Okay, ethane, ethene, ethyne. Yes, first, second, third. Very good. D option is correct. Very good. Okay, all of you, Ashish, Harshil, Vasant, Swasti, very good, beta. So, ethyne is most acidic, then ethene and ethane. This is the acidic strength. So, opposite to it is the basic strength of conjugate base. Okay, this is acidic strength of conjugate acid. Okay, so base strength is just reverse of it. Okay. Next question is wait. Most easy question. Question is, which of the following is most stable carbocation? It is from means basic CH3 positive. You should write the explanation as well. Okay, CH3 CH2 positive, CH3 CH positive, and D option is CH3 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 positive. Yes, what is the order of stability? Yes, beta. What is the order of stability of this carbocation? These carbocations. Just write the order of stability. Yes, because in case of D, there are 9 alpha hydrogens. In C, there are 6 alpha hydrogens. In B, there are only 2 alpha hydrogens, no alpha hydrogen. So option D is correct. Good. It is easiest part of this question. Okay. Yes, beta. Next, decreasing order of stability of ions. First is CH3, CH positive, CH3. Second is CH3, CH positive, OCH3. Third is CH3, CH positive, COCH3. Option A is first greater than second greater than third. B is second greater than first greater than third. C is second is greater than third greater than first. D is third is greater than first is greater than second. Yes, beta. What is the order of stability? Again D. Sure. Yes, beta. What is the order of stability? See, in the first case, there are again hyperconjugation. There are 6 hyperconjugated structures. Okay. In second case, see, there is plus R effect from one side and 3 hyperconjugated structures from other side, because there are 3 alpha hydrogens. In third case, CO is C double bond O. That means it is electron withdrawing group. This is electron withdrawing group. Minus means it is electron withdrawing group. Here it is electron releasing group. So electron releasing effect is maximum in second, then it is first, and then it is third. Because electron releasing group increases the stability of carbocation and electron withdrawing group decreases the stability of carbocation. So there are 3 hyperconjugated structure from one side in third, but on the other side there is electron withdrawing group. That's why stability of carbocation decreases. Okay, so obviously second is more stable than first. Third is more stable than first. It is not true. Say in this case, both sides there are releasing groups. But here on one side there is a releasing group, on the other side there is electron withdrawing group. That's why I mean to say in the first case there are both electron releasing groups. In the second case even there are electron releasing groups, but in first case electron releasing effect is due to hyperconjugation only, but in second case on one side there is hyperconjugation, but on the other side there is resonance, and resonance is dominating over hyperconjugation. In the third case there are three hyperconjugated structures on one side, but on the other side there is electron withdrawing group instead of releasing. So obviously electron releasing groups increases stability of carbocation, but electron withdrawing groups decreases stability of carbocation. That's why your B, second, first, third means B option is correct. Okay, got it? Any doubt, beta? Yes, beta, any doubt? Okay, so this is the question. Now wait. One last question we will do. Wait. Yes. Next question. What is the decreasing order of strength of the base? OH negative, NH2 negative, H, C triple bond C negative, and CH3, CH2 negative. Yes. So what is the decreasing order of stability of the base? Strength of the base, sorry. Decreasing order of the strength of the base. Decreasing order of the strength of the base. Yes. Which one is most basic and which one is the least basic? I have already told you that strength of base is proportional to electron donating power. A, B, C, D. Decreasing order. Or you are writing increasing order. ADCB. See, in first case, oxygen is most electronegative, nitrogen is less. Beta Basant, OH negative is least basic. Negative charge is more stable on more electronegative atom. Negative charge is more stable on more electronegative atom, right? So negative charge on oxygen is more stable, so it will not donate easily. So, and here carbon is sp hybridized, here carbon is sp3 hybridized. So sp3 hybridized carbon is least electronegative. First I write order of electronegativity. Then sp hybridized carbon, then nitrogen, and then oxygen. This is the order. Okay, so sp3 hybridized carbon is least electronegative, so it can donate effectively. So CH3 CH2 negative is most basic, then ethyne and ethynide, then NH2 negative, and then OH negative, amide, then hydroxide. Okay. Above all, if we compare acidic strength of its conjugate acids, you know which acid is most acidic? Obviously water is more acidic than ammonia. Sorry, water. CH3 NH2. And now if we compare these two, HC triple bond C negative and NH2, you know, carbon and nitrogen, nitrogen is less. Nitrogen and sp hybridized carbon is almost of same electronegativity. Keep in mind, nitrogen and sp hybridized carbon is of almost same electronegativity. When we compare nitrogen and carbon, we take both as sp3 hybridized. Okay, and then we compare that nitrogen is more electronegative than carbon. Okay, but when we have sp hybridized carbon, then it is equivalent to nitrogen. Both are almost of the same electronegativity. Okay, so that means this order is like this only. This, then nitrogen and carbon, so electron density is more on, electron density means lone pair density is more on nitrogen, so nitrogen can donate more effectively than HC triple bond C negative. So it should be like this. Because if we compare these, obviously CH3, ethane is least acidic. Then there is, ammonia, and then ethyne. Ethyne is more acidic than ammonia. So obviously, which in turn less acidic than water. So this is the order of acidic strength of conjugate acids. Okay, so obviously the order of basic strength is just reverse. Okay, we can compare in both ways, right? So that's all for the day. Thank you so much. Bye bye beta. Next lecture may be of the same type. Okay, any doubt? Yes beta. Yes beta, any doubt? Okay. So thank you. Okay beta, bye.